actually not a talk about server components. No, you don't need to rewrite your app to use server components. Do it incrementally. Anyway, so throughout this talk, you might be thinking, what is he doing? Why is he doing this? And the answer is that because I want to, because I can. So maybe just stick with me. The talk is actually not about how to build a video game. The talk is about how not to build a video game. And so to start off, I just want to jump in and show you a video of this game. So this game is called Athena Crisis. It's a 2D turn-based modern retro strategy game. It's similar to games that some of you might have played when they were younger. And the reason why I chose to build a 2D game with pixel art is because that's something that as a single indie developer with a bunch of artists, you can reasonably create. If you go into like 3D game development, it gets very hard, very expensive. And so in this game, you can control a bunch of units, you can move them around the field, and then you try to win, or sometimes you might lose. So I'm just curious, did anybody, sorry, there's no sound today, but did anybody notice something funny about this, or something weird? So this was actually a real game, and the AI was just playing against me. I can just jump in here and play against the AI. You see a bunch of things moving around. I can use this, play with this unit. All right, and so one more thing is that this video game is not just running in my presentation. This video game is actually written in my, embedded in my presentation, which is written using MDX, which is a dialect of Markdown that allows you to embed React components. And it has had module reloading. So I can just change it around, and then everything breaks. This keeps happening. I think what happens is when you switch the displays, things break. Same thing happened last time. Yeah, it's React. I also save while I'm typing to get the hard module reloading to work. OK, there we are. OK, so I think it's something about saving while I'm typing and hard module reloading. So it does work. And I can move around here, and I can swap it out again to the previous version. All right. And so once I realized I can put one game into my presentation, I also thought I can put 3 of them in there. It's kind of like, I've never been to New York, but people tell me this is kind of like playing speed chess in Central Park. And in this case, I just told the AI to play against me, and so that's what it's doing. Once it's done, I can jump into any of those games and play against the AI. All right, here, for example, I can just start moving around. I also realized I can just, because this game is available in various different languages, and it has internationalization, I can just change the language of this presentation as well. And then I realized, if I can embed the game, how about embedding the map editor that I built for this game? So for example, here, I can just pick whatever I want and just start drawing and making a map. And what I learned by building a map editor, what I wanted to do is that when a player builds their own maps or wants to share maps with somebody else, what I wanted to have is so that you can never create a map that is not playable or a map that doesn't look good, where some things don't fit together or where you have to spend a lot of time making them look good. And you only need 2 constraints for that. One is, can you place a tile on that field? Is it allowed based on what's around it? And based on what's around that tile, what should this one look like? And so you can start drawing. And the cool thing is you can do instant playtests. So you can just drop your units here in any color. And then you can just, with the press of a button, you can jump in and play. All right. So everything you've seen here is that something that was built from scratch with JavaScript, React, and CSS. And the stack is really amazing. It's using Beat, PNPM, TypeScript, React, Relay, Emotion, Prisma, GraphQL, GraphQL Pothos, Socket.io, and persistent data structures. So that's Athena Crisis. I used to work on testing a lot, so I also want to talk a little bit about the testing infrastructure. So when you're building a video game, you're making a lot of changes. There's a lot of complex state. There's mutations. There's all that kind of stuff that you're also doing in your forms and in your front-end code. And so I was like, how do I make sure that when I'm making changes, it doesn't regress, right? Obviously, you're going to go write tests. But there's a big difference between good tests and bad tests. And I thought, okay, maybe I can build like a map renderer so that I have a map, and then I move a unit from here to there, and then it renders it to like text, to like ASCII art or something, and I put that into like my tests. But then the problem is you end up having two different renderers for your system. You have two different, and they all like lose signal, right? Like, so you have like you saw all this art, right? And like there's so much going on. And if you start rendering that as text, you have to keep maintaining that, and then that just takes a lot of work. So I thought, what about screenshot tests? Just capturing the state of the map at that time, and then saving that as a screenshot test. And just as a quick example, this is the API that I came up with for writing tests. So for example, you have like a map, you execute a bunch of actions against that map, you get a response back, and then you capture a screenshot of that state. I just want to show you how that works. So I have my tests running here in the terminal. This is actually live. This is my test suite running. Test might fail. If it's flaky, we'll see. And the cool thing is that in iTerm and in some other terminals, you can actually print out images. So while I'm developing, I can see what's going on in my game and if the state is correct or not. All right. Why would anybody build a video game with CSS, the DOM, and React? Right? Like I said earlier, because I wanted to and because I can. That's really everything that we need to say. But no, I mean, what you saw here is there's a bunch of reasons, right? Like one is instant load times, right? Like this game loads in like less than 100 milliseconds. It runs everywhere. I can run it on my phone, on my desktop. It has smooth transitions, and you can get them pretty much for free with CSS. So for example, when I'm trying to build a unit, I can tap this like circular menu. That entire menu is rendered using CSS and variables. The only thing that I'm doing with JavaScript, I'm telling it how many units there are going to be, and all the math, everything else, is in CSS to lay out the circular menu. And when you tap it, you can see how it like kind of jumps out. It's just like a really nice, smooth transition. Accessibility, browsers have really great support for accessibility APIs, so you can make a game like this also available to people that might have partial color blindness, something like that. Light and dark mode. So I can just change my computer to dark mode, and then the game and the presentation are both in dark mode. I don't think it makes any sense to make a presentation in light and dark mode, but I got all that for free. Downside is, and you might know that also, is that you might have to fight with performance sometimes. And earlier I was talking about persistent data structures to declaratively describe game state. I did a version of this in Japan, and we had the slides translated, and I just could not translate that one. So the cool thing is that I have this map, and anytime you execute an action against the map, you get a new state back. But because it's persistent data structures, I can have like 100 states of the map, and it uses very low amounts of memory. And also the cool thing is that I'm declaratively describing the game state. I'm just giving this game state to a React component, and I tell it, hey, go figure out what that should look like to the player. And just to give you an example, here are like 30 maps. I just told the AI to play against each other, and then give me the game state and render each of the maps. And I put an FPS count there so that you can believe me that it's 60 FPS. But 30 maps isn't cool. How about 3,140 maps? We can scroll for a little while. But the cool thing is I can also just jump in and play at any state of this game. I can just go in. I can also tell the AI to play against me. And then we can like go all the way down. Oh, I saw a few frames were dropping. Can go all the way down. Yeah, the game is almost over here. So the AI is playing quite a while. All right. So that's persistent data structures and a way to declaratively describe the game state. All right. So now let's play a little game. It's called Is That CSS? It's actually not a very fun game, because the answer to every question is yes. So when I tap one of the units, all of the ones that you can go to and like you can attack, they get this like red outline. And I'm not sure if you see this, but when you actually tap the unit, like it like comes out. There's like actually a 200 millisecond transition there. I'm just going to prove to you that, I got hot module reloading working here. Let me just get this in here. So these units, they have like a red drop shadow, and it's just a CSS variable. So let me just turn that into yellow. Wow, none of the demos work today. That's fantastic. I think the WebSocket connection is like breaking. Okay, right, there we are. All right, let's just see if it works. Okay, there we are. I think it didn't like rendering 3,000 maps. Okay, so I can just change that. When we like zoom in here a little bit, you can see this building here. There's a unit behind it. And when there's a unit behind like one of these tall buildings, I try to fade out the building so that you can see that there's something going on behind. That's actually just a mask image with a linear gradient. And so if we get rid of that gradient, you'll see how that building is not transparent. It doesn't have this fade applied to it anymore. All right. Oops. When you like highlight one of these units, you see this arrow that tells you how this unit is going to move, and it has this marching ant. So I'm cheating a little bit because the arrows are actually using SVG. But then this marching ants animation, that's a CSS animation as well. And then do you see how this blue radius is like drawn? That's also just rectangles with a mask image and a linear gradient that's rotated and like turns off and on at certain steps. So yeah, it is CSS. If you're still not sure, I'll just go in here for a sec. Might be a bit hard to see in the DevTools right now, sorry. All right, yeah. We got all the units, everything here. That's, I think, the radius, and then the units are up here. There's a bunch of crazy CSS stuff going on, and I'll get to that in a second. All right. So one of the interesting things is that in games like this, you have something called fog of war. And fog means that you cannot, like, all your units have like a limited set of visibility, a limited range of visibility, and you cannot see anything that's outside of that range, and that's the fog. And so I went through a few iterations, but this is the simplest and most fun implementation that I've found. So this is how I'm rendering the fog. It's just a bunch of rectangles again. And then I apply a blur filter on it, and then I merge that layer into the layer below it to make it grayscale. It's pretty fun to play with this. And just to show you, when you move around, you reveal the fields around that unit. So for example, here, you reveal those fields. And when you turn off that filter, you have like hard edges. So that filter makes it look really good. For example, here, you see that this tree, the forest here is actually with using red trees. And you can kind of like see that shine through here. But if you make it look like this, it's just black. Let me just show you. Yes, those are red trees. All right. And just to explain it, so this is the really interesting thing here is that, you know, in games like this, if you play them like locally, then all of the state is locally on your computer or your video game system, right? But when you're playing a game like this online, you don't want to have the whole state on each of the clients. You want to have a server that controls what is visible to each individual user. It's kind of like privacy rules when you're like maybe making a Facebook post and you're like, I only want my friends to see it, not my acquaintances, right? And here you have a privacy rule on each individual field on whether that's visible or not. So here are two maps, and they're both having the exact same state. And I'm the pink player in both situations, and in the one with fog, I cannot see everything that's going on the map. And so I'm just going to tell the AI to play around. And it's doing the same thing, but on one side, you can only see the things that are visible to that player. And so, for example, I can tap this pink unit and just verify if it has the same state here. Yeah, it looks exactly the same. So, you know, obviously, if I'm a hacker, I can just go in, find that div with the mix blend mode and the filter that I showed you earlier, and just remove that, and then I see everything that's below it. That's not how it works. That state is not available on the client. It's just on the server, and the server figures out what is visible to that player. And then there's one cool thing that, you know, whenever you're using like a mobile device, especially iPhone, when you're typing something, and it will predict what is the next letter that you're likely to type. And then it will invisibly expand the area around that button. You cannot see that, but even if, for example, if it thinks that you're going to tap an E, but you like just get to the border of it and you tap a W, you'll probably still type out an E. And so the way it works is it actually increases the size of the touchable area of of that field so that you'll always tap the right thing. So it's kind of like predictive typing, right? So in here, in this case, what I thought about is that I want to make sure this game works really well on mobile. So it's kind of like, predictive playing, because I'm trying to figure out what is the player most likely going to interact with. So if it's your turn, most likely you're going to interact with your own units. So for example here, even though I'm on this forest, when I get really close to the next field, it will just grab the focus. So if I tap here, it will focus it. And then, once I focus that, it's like, what are you going to do with this unit? You're most likely going near another unit that's probably not yours. It's probably like from one of the other players. So even though here I'm on like the forest here, that helicopter unit will just grab the focus. So I can tap here, and it will still do the thing that I most likely want to do. And this is just a small optimization, but on mobile, it makes a huge difference in the user experience. Idle animations. Earlier, if you were looking closely when I showed you the dev tools, there was something like every 180 milliseconds, it was like flashing. And I found that CSS variables are just one of the most fun things and like one of the coolest inventions in like CSS. I grew up not having that, and like having that power is just really fascinating. So, we're all here in this room. We all breathe at a different cadence, right? And like a game like this, the breathing is a bit more pronounced. It's called an idle animation. It's not doing anything but breathing. And the thing with like CSS animations, that's the first iteration that I had here, was that when you add a CSS animation to an element, that's when that timer for that CSS animation starts. Or when you insert that element into the DOM for the first time. And so what happened is you're building units at like a different time, and then they were all out of sync. They were all like going up and down out of sync, kind of like us, but and that's more natural. But in a game like this, it doesn't look good at all. And so the solution I came up with is, so first off, on the bottom there, you see a sprite sheet. So there's like 48 tiny little images for each individual unit, right? And I just cycle through them every 180 milliseconds, depending on where it's which direction it's looking at, whether it's moving or whether it's just standing on the ground. And so the best solution that I found is that on the top level of my component tree, I have a hook that's called useTick. And every 180 milliseconds, it sets one CSS variable. And so each of the units just uses that CSS variable to offset which sprite to show. So there's no JavaScript running on each of the individual units. It's just at the top level. This is not very fast, but it's in sync. That's why we're getting to pitfalls and performance. So the game is actually rendered like this. And that is not very fun. If you have like a 30-inch screen, you'll probably not, even with some of the UX affordances about like, larger tappable areas, it's not very fun to play. So the first instinct is, oh, let's just use transform scale 3 to blow it up, right? But you can see that it looks a bit blurry, even on this screen. Sorry, it's maybe not as obvious, but it is like definitely very blurry. The problem is that by default, it looks a bit blurry. There's a CSS attribute called image rendering pixelated. That's exactly what I need for my use case. But the other thing is that there is a CSS property that was invented like 25 years ago, and it was only supported in Internet Explorer, and then Chrome and Safari and all of them had to copy it to be compatible. And for some reason, transform scale washes out all the colors, especially when you apply this like slight 3D transform that I have there. And with Zoom, you don't have that issue. Unfortunately, Chrome was about to remove this, but as far as I understand, I think Excel in Office 365 is using Zoom heavily, and apparently there's a couple 100 million users using that. So I'm really hoping that Zoom will stick around, or that we'll get an alternative that doesn't wash out the colors as much. And then I was very happy with 60 FPS in Chrome, and I went to Safari. I built my entire image rendering pipeline, image processing pipeline. I took all these sprites, and I just base64 encoded them into a single CSS file. And I'm like, this is amazing. There's one JS file, one CSS file. That's the entire client, right? And I learned that in Safari, for some reason, it wasn't running at 60 FPS. And you saw this earlier where I'm like, doing these idle animations every 180 milliseconds, and let's say there's like 50 units or 50 entities on the screen that are like changing what they look like every 180 milliseconds. And I learned that Chrome has a cache for like base64 encoded images inside of a CSS file, but Safari doesn't. So every 180 milliseconds, Safari would look at this base64 encoded string and be like, never seen that before, let's figure out what that looks like, decode the base64 string, turn that into an image, and then render it. And obviously that didn't work so well. So what I did is I deleted my image processing pipeline and just went back to regular PNGs, and that gave me like 10 to 15 FPS in Safari. And the point here is that if you have static images, base64 encoding them is probably a good idea. If you're manipulating what they look like on the screen by like, changing the background position of like an image, or like of an element that renders a background image, and if you do that quite often, it might not work as well. And then in terms of performance, this is my daughter. This is Mia. She's 5 years old, and she comes to me. It's like, hey, Papa, I want to help you make your game. And so I said to her, OK, here's the map editor. What do you want to build? And she came, well, these tents are kind of cute. I want to put one on each field. And so she did that. And that shouldn't be an issue, right? There's like maybe a little bit of a campfire there that's like animated, but shouldn't be a big deal, right? Somehow, in Chrome, in every browser, frames per second went down to 7. It was not very fun to play. And so, did you see this earlier? I mean, I showed it, but like when you're playing the game, when you tap a unit, all of the things that you can attack get an outline. And I really wanted it to like come out in like 100 or 200 milliseconds, kind of like, not just appear, but like have this like slight fade applied to it, because it just looks really good. Well, it turns out, even though on the internet people will say that transform and filter are GPU accelerated, they're good filters and bad filters. So in order to get this fade to be just right, you actually have to initialize some of the values. So the way I'm doing this outline is I'm actually using 4 drop shadows with 0 blur, 1 in each direction at 1 pixel. That gives you like a pixel perfect like drop shadow. But then the problem is I had to initialize it to be transparent so that once I turn it into red, I get this like nice animation. And so I put this drop shadow that doesn't do anything. It's not visible, right, because it's transparent on every single entity in the game. And browsers are like, oh, cool, there's a drop shadow. Then, I don't know how to optimize that, and everything got super slow. So what I learned there is that, there's some good filters and some bad filters. For example, using brightness, saturation, and grayscale is always very fast. Drop shadows can, you can fall off a performance cliff. And then, I had some other performance problems, and I saw this CSS prop. It's called will change, and it's amazing. It's like, hey, will change, with will change, you can tell the browser, what you're about to do, because, like, it will then figure out to do the right thing for you. And I thought, man, I'm so smart. I'm so much smarter than browsers. I know exactly what's going to change. And so I just put this, like, 2-line change into my code base. And then a few days later, I'm like, things have gotten kind of slower again. And then I realized, actually don't use will change, and maybe read the documentation, because I definitely didn't. So the interesting thing about this one is that it doesn't make things faster by optimizing it better because you tell it to optimize. What it does, it bypasses all the caching that a browser normally does, because browsers are really smart, and you can just tell the browser, actually, you don't need that cache. But most of the time, what I learned is I'm not much smarter than a browser. And browsers are very good at caching things. And so I stopped using it, and it's been much better for me. Maybe I should change the headline here to like read the documentation rather than not use it. There are some use cases. There's a red box there. Read the red boxes on MDN before you use something. The other thing that like is just really awesome is to always use an FPS meter. Every single page in a game, everything that you can see while you're developing, it always has an FPS meter on the bottom. You saw that in like some of the slides where I was like trying to prove to you that it's really fast. And it's just because when it's right there on the screen at all times and it drops, you know that you're having an issue. You don't just, you don't just like go into the DevTools and it's like, oh, I measured my performance and I realized now it's slow. You have it right there every single moment while you're developing. And that's super useful. Another piece of advice is that, and I think we're talking a lot here about, server components, and people are like, okay, that's going to be so much faster, But quite often it doesn't really matter, right? Like it doesn't matter if you don't have any users, if your app is any faster, right? So what I learned is to benchmark early and often, but only optimize what matters. So in this game, I still have a bunch of things that are slow. It doesn't matter. And I have a bunch of things that were slow that I went on optimizing. So for example, I built this AI that you saw earlier, and I thought, man, I'm going to, I didn't know how to build an AI, but once I started building it, I thought, I'm going to build the most beautiful functional programming-based AI that I can ever imagine. And I did like, reduce, map, filter, max, by, sort, everything, and it just, allocated a lot of memory, threw it away, and then mapped over it again and created some other objects just to like, build this beautiful AI. And then, it took like 2 seconds. And on the back end, that wasn't a problem. I didn't even notice. But then I wanted to run it locally, like in the map editor. And every time I ended my turn, it like does the entire thing for the next turn. And then, my browser locked up. And I'm like, OK, now I'm going to figure out how to put this AI into a web worker because it's so slow. And it's like, creating a bunch of complex infra to run the AI elsewhere. And then I realized, what if I just analyze my code and make it really fast, right? So I was actually able to just get rid of a bunch of that, functional programming of those patterns that tend to be really slow in JavaScript, make the AI about 30 times faster. Well, it took about 2,000 milliseconds, and now it's about 37 for like the same amount of work. And I didn't have to do any of that complicated work, right? Like I can also pause it, so I can just, use an idle frame, like figure out if the AI is doing anything or not. For example, while a unit is moving, I can have the AI figure out what the entire next turn should be. So now I don't have to build a bunch of complex infrastructure. And then in terms of tooling performance, I built this like library to do palette swapping. It's still not fast. I can improve it, but I just built it. And I built the entire thing while carrying a baby. And then it worked for me. It was great. But at some point, I thought, this thing is a bit slow. And so I looked into it, and I sped it up by 23 times. It's still not good, but it's a lot faster. What I learned there is just don't trust anyone carrying a baby and shipping open source. And yeah, I'm trying to open source as much as I can. It's not enough yet, but there's a bunch of things on my GitHub, a bunch of stuff on my blog that I wrote about, and there's more to come. And yeah, I recently started a video game company in Tokyo, and this game is going to be shipping in a few months, hopefully. So thank you so much.